Okay, now we're on page 64 of your workbook. This is Geometry Part 2. So we're looking at similar triangles, example 6.1.4 or section 6.1.4, and then example 6.8. Again, you'll just do some classwork throughout, or practice problems basically, and do those on your own and then check your answers. Two triangles are congruent if they are exactly the same size and shape. So they really have to be exactly the same. In congruent triangles, the measures of corresponding angles and the lengths of corresponding sides are equal. If the corresponding angles of two triangles have the same measurements, they are called similar triangles. So they have the same angles but not the same sides. Similar triangles have the same shape, not same size. When a pair of triangles is similar, the corresponding sides are proportional to one another. Okay, so this is a good review of proportion, and we'll do more of that in the next unit before we do problem solving. We do a lot of proportion in statistics as well. So determine the length x of the missing side. Assume the triangles are similar. So they tell us that. And we also know that this is a right triangle too, so that's helpful. So we can set up a proportion for this. So proportions, you may recall, if I have A over B, that equals C over D, and I get that set up, then I can actually cross multiply to solve algebraically, right? So if A over B equals C over D, then what happens is AD equals BC. So we can actually, when I do this, we're multiplying on the diagonal over the equal. Okay, so that's very helpful. So we're going to say that this side, 66 feet, is to x feet. So I have 66 feet over x feet equals, now make sure you have the large triangle. If I'm doing larger over smaller, okay, and I have my stuff for the longest on the top, longest side, and then this is going to be the other, is on the over here. This one is the other. So we'll do that in orange. Okay, and then the other is going to be in the purple, right? So we have to take the one from the large, 42 feet, over the one from the smaller triangle, 35 feet. So that's how they're set up in proportion. I could do it differently, but as long as I'm consistent, and it would work out. So first I'll show you this process, doing it as 66 over x. So the hypotenuse over hypotenuse, I have the large over the small, and then side A, or leg A, from the larger over leg A from the smaller, and then I'm going to cross multiply. So we're just going to go like that, right? So then I'll have 42x from this one. I just multiply those together. And then I'm doing 66 times 35. And because it's commutative and it's equal, it's okay. I don't have to do the 66 times 35 on the left side or whatever. It's fine. And then I'm just going to go ahead and divide both sides by 42. I could have calculated that out first if I wanted to, but if they're small numbers, sometimes I like to just reduce ahead and kind of keep it in my head. So then just crunch the numbers on this and calculate them out and divide by 42, and you should get 55 feet. So that's what this is equal to. Okay, so the sentence would be the missing side is 55 feet. Long or something like that. Okay, so you have all your pieces for your problem solving process. So keep that in mind as you go. Make sure that you're labeling everything, putting the units in, declaring unknowns, that kind of stuff. Like this one is clearly labeled on the side there already. Sometimes it's just given to you as such. Now this example 6.9, if you want to try this one as a classwork, you're going to pause and complete and then check. So make sure you're right. You can just check it right in the video. If you wanted to just, go back and look at it later, but you'll see the answer when you come back to it. I'll have the answer there for you. Okay, so I gave you this setup here just to make sure you have that down before you crunch the numbers. I have this kind of shorter leg on the smaller triangle over the shorter leg on the larger. That's that first ratio. And then I have 42 over 63 here. Match those up, and then I'll cross multiply and do it out, and you should get 10 meters. So go ahead and try that. I did want to go back up here because I want to show you how if you just did it a little bit differently, like say I wanted to set up my proportion in a different way. Like I wanted to, instead of doing triangle to triangle, I want to do within that, I'm going to do long side over, or the hypotenuse over leg A. I would do over here, hypotenuse over A. And I could actually set that up as 66 over 42. And then I could do the same here, x over 35. So this is just like a different method. As long as I'm consistent, when I multiply that out, you can see here how that's going to work. I get the same thing. 42x equals 66 times 35. And I clearly divide by 42 the same way I did before, and I get 55 feet also. Okay, so that's what, just a different way you can set it up, doing the hypotenuse over the leg for one triangle, and the larger is the 66 over 42. Set that equal to the x over 35. So really it just depends how you're kind of looking at it, and you have the variety to do that. I just chose doing it this method because I think your book does it that way. But either one is fine. The key thing is be consistent in what you're doing. Like I wouldn't want to crisscross. Like if I had 66 over 42 here and then flip-flopped 35 over x, like that wouldn't work. You can't just randomly place the numbers. You have to really make sure you're methodical about that. So just wanted to mention that, and feel free to set it up. As long as you're consistently correct, then you'll be in good shape. Now you've probably done quite a bit with perimeter, circumference, area, especially if you just had the math 95 or something like that, right? So we're gonna just quickly go over these. So polygon is any two-dimensional figure made up of straight sides. Quadrilaterals are four sides. The sum of those interior angles is 360. Different kinds of quadrilaterals that we have are parallelograms. They have opposite sides are equal, so they're kind of slanty like that. Rectangles have 90 degrees, and parallel sides have equal lengths. They also have, sometimes you just put these little, squares in there, or one of them, just to notate that's a rectangle. A square is a special kind of rectangle. So actually all rectangles fit the parallelogram description, don't they, right? And then rectangle is even more fine-tuned, having the 90 degrees. And then squares, you could call a square a rectangle, but not any rectangle is a square. So you just have to keep that in mind. So all the angles are 90, but they also have an added feature of equal length. Okay, so when we're talking about area of a square, for instance, we could just say side squared instead of length times width, but you could also just say length times width. That's fine. Rhombuses are a pretty cool shape. Opposite angles are equal. All sides have equal length. Kind of looks like a diamond or a kite. And to work with these, sorry about that, we have example 6.10, find the missing angles of the quadrilateral. So what did we just learn about that? What are the angles equal? It was, let's just check back up here, it was 360, right? So if you know about the quadrilateral, go back here, opposite angles are equal. So we know that this one has to also be 60. So we have two of the angles. We don't know what these are in here. These are question marks. So we're going to call that X. But we know that they're the same. Right? And we know that all the angles have to add up to 360. So I would say let angle 2, because angle 1 is given as 60 degrees, right? And we'll even call that, okay, let's do this. Angle 1 equals 60, and also angle 2 equals 60. So we'll number these as 1 and 2, and these as 3 and 4. So then we're going to say angle 3 equals X, angle 4 equals X. So we know all together that they have to add up to 360. So we're going to say angle 1 plus angle 2 plus angle 3. Hopefully you're seeing a shortcut here too. Equals 360. And I know these are the same, so I could actually say 2 times 60, right? And then also these are X, each X, so I could say 2X equals 360. And now you can go ahead and solve that out. So go ahead and take a minute to do that. You can pause if you want, or just kind of do it along with me. And then I would have 120 plus 2x equals 360. Subtract my 120, I get 240. And then x equals 120 degrees. So these are each 120. And you can just answer in a sentence, angles 3 and 4 are each 120 degrees. You can just use a little symbol for angles or write the word out. That's nice too. And let me know if you have any questions. You can write in the comments of the submission box. If you write it on your notes here, I won't necessarily see it promptly. So go ahead and just send me a note, or if you see something that doesn't work out right, or you think I have made an error in any way, just certainly let me know. That'd be great. Okay, so then we have a blank page, and now we're jumping up to page 67. Okay, 6.22 perimeter and area. So the shapes that we talked about before, parallelogram, the perimeter is the sum of the sides, the area is the base times the height. So this would be, the base is the length that's straight across, and then the height is always at a 90-degree drop. Okay, so be careful, because I don't want to use this side as the height. It has to be the 90-degree line up there, but I'm going to use the entire base, not just this little piece here. So just to clarify that, when they're on an angle like that, it's a little confusing. Rectangle, probably you're very familiar with this. Perimeter equals twice the base plus twice the height. Another way you've seen it is length and width. That's, you can do it that way too. Square, side squares, area. Perimeter is just add up the sides. Perimeter for triangle, add up the sides. Area is half base times height. And again, depending on the shape of the triangle or the type, the height has to be from a 90-degree drop, but the base is this whole entire bottom. And if it's turned, it's kind of turned in a weird position. Just get it so that this height goes down at whatever the 90-degree perpendicular line to the base. Make sure you have that whole base in there. Another key note, this is written here, but really make sure that when you are solving out for area, use square units, and make sure you write that in your answer, that it's square units, and the edges, if you're just doing perimeter, that's in linear units. Sometimes we use these little symbols here, like instead of square feet, we'll say feet to the second power of feet squared. That doesn't mean then square the number part of the answer, only just the units, because you've already done that multiplication. It's just saying, if I were to fill this in with little squares, right? So find the perimeter and area of the quadrilateral. So if we look back up the top here, we have our area of the parallelogram, is what that one looks like right there. And we're going to do height times base for the area, and the perimeter, we're just adding up the sides. Okay, so perimeter, sum of sides, if you want to write that out. And then area equals base times height. And remember, the height is going to be what's the perpendicular drop here. And we don't have that written in, but because we have this dashed line and we're saying it's quadrilateral, that is assumed. Okay, so that's the height. This whole thing is the base, and this is a side. So the side right here, that 2.3 doesn't get factored into area, only in for perimeter. So we know opposite sides are equal, so this other side here is going to be 2.3 centimeters. We know this opposite side of the base is 4 centimeters. So let's do perimeter first. So perimeter is going to be 2.3 plus 2.3, or you could just do twice the side, right? But make sure it's different from a rectangle. We're not just going to do twice the height. That's not even involved with perimeters. So say not part of perimeter. Sometimes I just see that in there. So be careful of that. And then I'm going to add in the 4 centimeters and 4 centimeters. So the perimeter for that is going to end up, just calculate those out. So go ahead and do that. And we end up with 12.6 centimeters. And those are just linear units. And this is pretty generic, so you don't really need to write a sentence. Area now is going to be the base times the height, and my height is equal to 2 centimeters. My base is equal to 4 centimeters. So it's kind of like a triangle, but I'm doing the whole thing, not just half of it. So it'd be 2. Oops, base is actually 4. I'll just write it in the same order there. 4 times 2. And then 8. And for this one, though, because I'll show you here, this was actually, it's 4 centimeters, right? If I wrote that out, let's just write that out as 4 centimeters times 2 centimeters. 4 times 2 is 8, and then centimeters times centimeters is centimeters squared. Or you could write it as 8 square centimeters if you like. Okay, now these are kind of fun perimeter ones to do. You have multiple tasks though. You have to figure out the missing sides. You can't just take it at face value, and you might have to do some Pythagorean Theorem as well. Note that it's not drawn to scale, so measuring isn't going to work real well. Even if you figured out the proportions, obviously it's not in yards. But we're going to find the perimeter and area of the shape below. So the perimeter, we're just adding up sides, except we have one missing. So we have this chunk that we have to figure out. So that is a question mark there. So how can we kind of find what that is? So think about that. How would you figure out that missing side? Because you can add up for perimeter, but we don't have everything. So we have 4 plus 6 plus 7 plus 5 plus question mark. Right? So let's think about that. So one thing we can do is, if we knew what this piece was, if we knew what that was, then we could figure this pink part out up there, because we could subtract it from 6. But we don't know this side here that I just drew in blue, but we can use the Pythagorean theorem, because that's a rectangle over here, so that's going to be 90 degrees. So I can figure out some things. I would have to know just this piece of my Pythagorean, right? I have C equals 5, right? I have this whole thing here is 7, but I only want this blue, but I know this piece is 4, directly opposite, so that's 4. So this part has to be 3. And yeah, this is really not to scale at all. Kind of a weird problem. Maybe that's just so you don't look at it and try to figure it out by measuring. So this blue piece, sorry, this, just write it like this way, is 3. And we'll call that A. So then we have a squared, actually I'll do it down here, a squared plus b squared equals c squared. And we need to find b. And so a squared is going to be 3 squared plus b squared equals 5 squared. And so that would be 9 plus b squared equals 25. And then subtract the 9 and we get 16, and take the square root of both sides, we get b equals 4. Remember, we just want the positive, right? It would really technically be plus or minus, but we only want the positive. So this is going to be 4, this little piece here. If that's 4 and this whole side is 6, this is going to be 6 minus 4, so it'll be 2. Oops, that's kind of thick there. So that's 2 right there. Kind of a lot of work to get from point A to point B, but we really want to use those kind of tactics in showing you, you know, how something can look one way. It's not to scale, so it's kind of off, but we can figure it out by process of elimination and using our skills. So the Pythagorean theorem is a really important skill. So our missing piece was that 2. So now we can just add that in over here, right, with our question mark is now 2. And tally them all up, and we get 24. Okay, so now for area, we've kind of have a good setup now too. So we have this rectangle here. And we know that the area of that is going to be 6 times 4. And then we need to add that. That'll be 24. And remember that it's square yards. So I'm going to write yards squared, but I'm not going to square the 24 again or do anything with that again. I'm just going to leave it. That's part 1. And then we also have part 2 that we have to do. We need the area of the triangle. And it's nice we already figured out this height. So the height is going to be, that's half base times height. Height is going to be 4, and my base I already figured out also is 3. So the info I had to figure out just to get that one little piece for the perimeter is really helpful for area too. So make sure you recognize and keep track of everything as you're going. And then that will come out to be half times 12, which would be 6 yards squared, and that's part 2. And we're going to have to add these two together. Right, so the total area is going to be 24 square yards plus 6 square yards equals 30 square yards. Okay, so that one's gonna wrap up this video, part 2, which is focusing on the area, perimeter of the parallelograms, rectangles, triangles, that kind of stuff. We'll get into the circumference and area of circles in part 3. So thanks for watching. Have a great day.